Next question, fight fire with fire? No? Haven't heard that? Fight fire with fire? So, I call that fighting fire with fire because you're using something like S, which has like many terms in it, to fight S. And you kind of get rid of most of S that way. Okay? Anyway, whatever you call it. Okay, so we have this. Did everyone follow this so far? Okay, now we can simply factor S out of both of these terms. So we get this, S times 1 minus R. Okay? And then we can take then we can solve for S by bringing this to the denominator. All right? Does everyone follow that? So you can look this up and review it yourself. It's called geometric sum. Okay, it's not quite at the beginning of it, but it's down here and here. Okay? And so finally we get that S equals, equals this. Okay, now what was S? It was this long thing here. Right? And now we have a kind of what they call a closed form for it. Okay? And like a much shorter version of it. Alright? So, of course, now we can use that to do this annuity problem. Right? Because we already identified what is A and what is R. What is A in our sum up there? The thing that we keep multiplying each term by with is what? Is the present value, or 100, right? Okay, and what is R? The thing that we're raising to various powers. So it's 1 plus 0.003, or you can also say just 1.003, right? So that is R, and the other thing is A. So we can just take this formula, and we can tell what the sum is now. S, that is the future value, is equal to, according to this formula, 100, and then what does it say? 1 minus R to the n. It's not R to the 23rd, it's R to the 24th. Okay? So, what is it? 1 minus R is 1.003 to the 24th. Is that right? Why do I have that? Yeah, okay. And then 1 minus R. Okay? And now we have the future value for the annuity. Okay? So we could do it. Right? Looks like it's a really horrible mess, but some clever person did this and made it much easier for us. Okay? So now we can collapse that whole long thing into just this. Okay? And that's the value of our annuity. Okay? Any questions about that? Okay. So, let's see. Let's do some homework problems. Let's see what we'd have to do for homework. Okay, so we have compound interest and annuities are due on the 16th, and also something called more simple interest problems. Okay, so these three are due in next Wednesday. Okay? So let's look at the annuities problems. Okay. So how about this one? Okay, what does it say? Find the amount accumulated, the future value, in the given annuity account. Okay. Assume end of period deposits. What does that mean? Well, that's what we said, right? We're going to deposit the money at the end of each period. Okay? And what does this mean? And compounding at the same intervals as deposits. What does that mean? So we said we're going to compound 12 times a year, right? That doesn't have to be true, but we're assuming that we're going to compound at the same rate that we're making the deposits. Okay? It doesn't have to be that way, but that's what we're assuming. Okay, so what are we? How much are we depositing each month? Or we're doing it for each month? $200 for 16 years, and we're getting 6% per year, which is super high, right? Okay, so what's the minimum that this could be worth? It's going to be, we're going to do this 12 times a year, right? So that's what? $2,400 a year, right? So times 16, right? That's the absolute minimum, right? That's if you didn't get any interest, right? It would be 2,400 times 16. That's how much you're actually putting in, but you're getting interest. Okay? So how do you do this? You just fill this like this, right? So instead of 100, you have what? 200. Instead of this rate, we have what? Is that right? Yeah, 6% per year. So, but we don't want, that's, R and I are not the same thing, right? So this is R. So what is I? It's this over 12, right? Which I guess is 0.005, right? Is that right? No. Is that right? 0.0005. 0.0005. Okay, so then it's 1.0005, right? Goes there. Okay, and then the last thing we have to figure out is this. Right? Now we're doing it for 16 years and every month, so it's 12 times 16, right? Which is 160 and 32, 192? 192. Okay, so it's 192. Okay, and that should give you the right answer. All right, does anybody have a question about that? Any question? Okay, let's do one more. These are all the same problem, actually. But anyway. Okay, this is a little different. So what's different about this? So it says find the amount accumulated FV in the given annuity. Okay, there's a little difference here. 190 deposited monthly, that's basically the same thing as before. 20 years, okay. 3% per year, okay. But what? This one is not 0 at the beginning. So I don't know what to do about this. I guess what you do is, what should we do? How should we handle this piece here? Just figure out what? Yeah, just use compound interest for this one piece. Just figure out what the 19,000 will be at the end of the 20 years, right? And then add that into this calculation. So we're going to have this calculation plus the future value of the 19,000, right? So we handle them separately. That's going to be, I don't know if there's a better way than that, but that seems like the easiest way, the most straightforward way. Okay? Any questions about that? Did anybody have any questions about that? So let's say it again. So just, what I would say is just ignore this for the time being, at the beginning, and just do the same problem that we just did before, So you get this part, you're going to get some number for this, right? The future value of this. And then treat this separately like it was in a different bank account. Okay? If this is in a different bank account, what will it be worth at the end of 20 years if you get 3% per year and you're compounding monthly? Okay? So you just treat like that. I think that's the best way to think about it. Treat it as though it's in a different account. And then you just have how much you have at the end. You have the sum of the two accounts. Right? Any question about that? Okay, so have we done this enough? Or do we need to do another one? These are all the same. Fine. Oh, well, this one's a little different. Okay, this one says, find the payment that you have to make every month. Okay? How much do you have to put in every month to have $20,000 at the end of 10 years? How much do you have to put in every month? Okay? So that means that we're trying to find this number, but we're given this number. Right? So you have to do a little, you just take this to the other side. You have to, anyway, you just take this part to this side because you're given this, bring this over there, and you've tried to solve for this. Okay? Everyone follow that? Okay? Yes? Okay, let's do an example. Okay, so let's do this one. So let's rewrite these, rewrite that formula in terms of the symbols. So what's this formula in symbols? The future value is the S, right? Right? And this is called PMT, I guess, the monthly payment. Okay, that's the monthly payment. I think they call it PMT. And then we have something here. We have 1 minus, what's this? 1 plus I. Right? Okay, and what's this? 1 minus 1 plus I to the n. I think it's n, yeah. Okay? All right, so that's the formula. Everyone agree with that formula? Okay, now, if you want to know, if you're given the future value, like you are in this problem, you're given this is 20,000. So you're not trying to find the future value. Okay, so you're trying to find something else. They're asking us to find this given this. Okay? So what's the formula? PMT equals what? So I guess it's FV, and then 1 plus, 1 minus 1 plus I. By the way, what is 1 minus 1 plus I? That's equal to negative I, right? Right, that's 1 minus 1 and minus I. So that's equal to negative I, so we could put negative I there. And then here, we have 1 minus 1 plus I to the n. I hope we did this right. If we did, then this is the right answer. Okay, I'm not sure if that seems like something's a little bit off, but anyway, let's suppose this is right. Okay, so then if this is right, then you just put in 20,000 here and fill in everything else, and you should be able to find PMT. Did I do that right, by the way? Yeah. Okay? Does this make sense? Okay, now let's check it, see if we got the right, we actually have the right formula there. Let's see, what should we look up here? I guess we should look up annuity. Let's see if we look up annuity. Value of an annuity. Okay, so they do it like that, which is different. Rate per period, number of periods, P. So we have negative n. This is quite different. 1. Okay, let's look at this. Let me make sure that I didn't make a mistake. Let's just go through this, make sure I didn't make a mistake. Okay, here's the picture. Okay, so they did same thing, 24 months. So the last one is $100. The first one is this to the 23rd power. Okay? So they do this kind of thing. And they end up with this formula. Where, let's see, here. PMT, 1 plus I to the n, 1 plus I to the n. Minus 1, all right, that's right. So we got the same thing as they did, because I said there was a minus I, right? Right, didn't I say there was a minus I? But these two terms are reversed in my expression. So if you reverse mine, then you have to change the sign. Right, if I do this. So this is what I had, right? So if I do, and so, okay, so this is 1 times 1 plus I to the n, and then I had minus I here, right? That's what we said, right? So if I multiply both top and bottom by -1, then this becomes plus, and these switch. Right? So we get the same thing as they have. Okay? So then this should be right. Okay? Any question about it? You have a question? What's your question? Did I make a mistake? You what? You follow? It's okay? Okay. Let's see. They're probably here. They'll probably give us a solution for PMT. Let's see if we get the same thing. Okay, here's PMT. Is that what we wrote? PMT is FV. The top part is -I on mine, and the bottom part is the reverse of what they wrote. So that's the same thing. Right? Does everyone agree? Right? This is mine is minus I, and this is the opposite of what they have. So if I multiply that by negative, you get the same thing. Okay? So that is the PMT. Okay, PMT is how much you put in every period. It's called PMT. Okay? Any question about this? Okay, so you can do a lot of sort of variations on this, but I'm going to leave that to your finance course. Okay, the basic, you should just understand this basically what we did, and then there's a lot of sort of applications to this in finance. Okay, they talk about installment loans, like a mortgage. A mortgage comes from this kind of formula also. Because in a mortgage, mortgage means you're buying a house and you borrow the money and then you have to pay it back. And maybe you wouldn't be aware of it, but they make it so that you have to pay the same amount every month for, like 20 years or 30 years to pay back the loan for the house. Okay? So it's the same, it's related to what we did because you're paying the same amount and there's interest involved, and the math is closely related to what we did. Okay, but we're not going to go through that math, but you can see it's basically the same thing here. And bonds. What's a bond? What's a bond? So there's something called stocks, and there's something called bonds. And there's something called the stock market, and there's something called the bond market. So the stock market is what? Like, what companies can you buy stock from? Or say stock of? Which one? Yeah, which companies have shares?